but I don't know for sure. Oh, it is here? Oh, okay. Okay. The definition of a circle is all the points that are equidistant from the center. So if you think of it like a whole number, like maybe 3 units away, here is one point that's 3 units away, but there's like all these points all the way around that meet that definition. So this, it is a distance formula, which comes from the Pythagorean theorem. You could do it this one, this one, this one. Same distance formula, but they all represent that same distance from the center. So if it looks like a squared plus b squared equals c squared, because that's where it comes from. Drawing right triangles inside your circle. Yeah. Yeah, I'll leave that on here. Okay, that one should be in your notes, but yeah, I'll leave it up there. So this is clearly not the standard form of an equation. We are going to manipulate it until we get it there, and Bradley said, put the 9 on the other side, right? Okay, so step number 1, as you're looking at your notes, move the constant to the other side, and what do we do on the left at the same time? Rearrange it. Because we want it to look like this. We want the x's together. And I'm leaving a space because we're going to be completing the square here in a minute. And that's a -9 because I had to subtract it to get it to go over there. So again, once we get through this, I want you to think, which step might I get stuck on? And put that on your formula page. Jeremy, do you remember what the next step was? Complete the square twice. Do you remember what I need to do to try to complete these squares? So I always draw my little thought bubble over here. Anybody remember it? We take b, we divide it by 2, and we square it. That's how we find this number that'll make us have a perfect square trinomial. It's going to get us to this part. We get to come up with that number. So CJ, what is half of -8? Tyler, what is -4 squared? And I can't just add 16 to one side. What I do to one side, I have to do to the other side. Yes, sir. So it comes from the quadratic equation where this is A, this is B, and this will become C. So it's always that one that's by the X. I'm going to slow down a little bit. Yeah, this is for extra credit. Nope. I've had this one for a while. My $12 Walmart water bottle with my Hawaii. Oh yeah, then you don't feel sad if you lose it or break it. All right, Andrew, what do I do with the y squared plus 6y? What is that magic number that completes that square? What's half of 6? What's 3 squared? Yes. So if you need to put the little thought bubble, if you're getting stuck on that part of completing the square, like how do I find that magic number? I don't usually write it down. I usually have somebody do it in their head. But he said our magic number for this one is 9. Did we write a third step? Did anyone write the steps down on Friday? Factor on the left, simplify on the right. Okay, these 9s are going to cancel out. This is going to become just a 16. So what's my radius? Okay, so this is my radius squared, and Zara is right. That means my radius is 4, because that's what it's asking. What is the center and the radius? So we found the radius. It's 4. And then it says to factor the left, because we need it to look like this. So it's going to be x something squared plus y something squared. Is anybody good at these? There's a couple shortcuts. Martha, right here, what was -8 divided by 2? That's one way to figure it out. You could do the X Games. What two things multiply to be 16 and add to be -8? So there's a couple different ways to factor. You could stick that in your calculator and see where it crosses the x-axis. It's whatever way you are comfortable with. So, Lauren, what will go right here? Lauren, what will go right here? Here. How did you decide? What is your way of figuring that out? Yep, just b over 2. Okay, so if you're wondering, this is where most people are like, how did you go from here to here? It seems like a big mystery. What happens if I square this? If I do x minus 4 times x minus 4, if I FOIL it, I'm back to this. And same thing here. If I square y plus 3 times y plus 3, I'm going to end up back to this. These are equivalent, but if I complete the square and then factor it, it now looks like the equation of a circle. So Tyson, what is the center of this circle? Now that it's in the equation of a circle, what are the numbers that represent the HK, or the center? Yes, kind of. Logan, how would you change that? How would you change it? Yeah, so the subtraction signs come from the equation. So this subtraction sign is part of the equation. So the 4 is okay, but this came from y minus the negative 3. So what is the center? 4, negative 3, and Zara helped us with the radius. It is 4. Okay, there's one like this on your homework, so you have another one to practice. There's one like this on your practice test on Thursday. And I think if you just keep giving it your best each time you try it, asking for a little help where you get stuck, I think we can have that by Friday. It'll be nice to have that bonus problem. And then I think it says to graph them. So my center is at 4, negative 3. And I'm going up 4. Why, we've been doing these on our bell work, so. That was good. Gosh, that is so. I can just be done with life. That was so good. Okay. There's one new concept that's an extension from what we did on Friday, but not much of one. So before you start writing stuff down, let's read through this. Jesus, will you read it for us? No, Juan. Just fire me right now. We need to write an equation of a line. What information did it give us to help us do that? The center, but it was kind of cryptic. Luke, what is the center? Oh, you'd think, but it's not. You'd think that too, but it's still not. Yeah, why didn't it just say that? I don't know. But it does just tell you the center of the circle is at the origin, so you may want to write that down. Or like Luke, we jumped to conclusions so fast. Maybe it's that one, maybe it's that one. No, it's none of those two, it's the words. And it contains a point 2, 0. Paxton, how can we find our radius? How can we find our radius with all this stuff they've given us? What do you think, Sydney? So you can make this super hard and do like a distance formula and see how far apart these are, but like Sydney said, can't you kind of see how far apart these are going to be? Like this is the center. Here is 2, 0. So we've got this circle. So what's the radius? 2. So there's a hard way to do it, distance formula. But when you're given a point that's straight out to the side, we can just count. So our radius is 2. Will you take a second and write the formula for this circle? Here's our h. Here's our k. Here's our radius. And then simplify it so it looks nice. I know Ethan wasn't here Friday. Who else wasn't here Friday? Okay, so this is like a crash course. You might get stuck partway over. So plug in the H, plug in the K, plug in the R, simplify. That's the review. The new part is when we're going to prove or disprove that the point square root of 2 lies on the circle, and I'll show you how to do that. Okay, compare your equation with your neighbor, please. You have new neighbors, so maybe you don't know who they are. Paxton, this is Grace. Grace, this is Paxton. Logan, this is... You don't have to like him to show him your equation. Yep, so start with x and then minus, and then put your h. And then close parentheses squared plus parentheses y minus, and then k. Oops. To 0. Andrew, Sarah, Andrew. You guys get to show left and right. You moved on. You guys comparing equations? Some of you haven't done it. Sorry, I messed your name up twice. I'm actually like the most embarrassed I've been the whole year. Have you had braces the whole time? My son needs braces. I'm not excited for that. You guys get the same equation? Are they matching? I'm seeing some that are kind of ugly still. If it's a 0, you can do x minus 0 is x. And what's y minus 0? So you can make this look really pretty. You picking up on it a little bit?
Wait, crap.
Not yet.
What? Does this look right?
You can put a number in for r. We know r. All right, Porter, what's your equation? Well, what do you have so far? CJ, should make him start. What is x minus 0? What's x? Take away nothing. Yeah, if you have a 0 in your center, you don't have to write that necessarily. Okay? Keep going, CJ. What else?
Plus y minus 0 or just y squared.
What will it equal? Okay, this should be the review. Some of you are either refusing to do it or are confused, which is okay. That's why we're taking the time to do it. So I'm not really sure how far over the square root of 2 and the square root of 2. It's definitely somewhere around here. I need to find out if it's right on the circle. So I'm going to plug this in for x, and I'm going to plug this in for y, because these represent all the points on the circle. So we're going to see if it is 1. So square root of 2 squared plus square root of 2 squared equals 4. We're going to plug in an x and y and see, is it on the circle? If it is, you'll get 4 equals 4. And if it's not, you'll get like 5 equals 4 or something. Sarah? Because they were 0. So you could do square root of 2 minus 0. When there's zeros, it makes it a little bit easier. Okay. If you love squares and if you love square roots, you could do this in your head. Can this make sense? And if this looks like a total disaster and you're just going to wait for me to do it, plug that into your calculator. So plug it into your calculator. Paxton, have I put you to sleep already? Yes, I have. You can just be honest. Yes, you put me to sleep. Me? Rude. All right, Emery, what did you get on the left-hand side? 4. The square root of 2 squared is 2. The square root of 2 squared is also 2. And it does equal 4. So the answer is yes. The point square root of 2, it is on the circle. So crazy. And they usually pick numbers that aren't really easy to figure out from a picture. Okay. Let's try one more. Prove or disprove that the point 1 square root of 5 lies on a circle centered at the origin and containing a point 0, 1. Ambrose, where is the center of this circle? 0, 0. Jeremy, what's the radius? 1. How did you know that? It didn't tell us that. Yes, so you can think of the picture, you could draw the picture. It's not always going to be that easy, but these ones are. Please set up an equation. Everybody, not half of us, even CJ, even Porter. Write an equation for this circle using HK and R. You just went right to checking to see if it was, well, you must have kind of done it if you plugged this into it. Oh, I see. Write the equation for this circle. Plug in 1 square root of 5. Got it? It's going to look a lot like the other one because the only different thing is the radius. Dang it. So Sarah, what does your equation of the circle look like? Yeah, so it looks so much like the other one because it had the same center. So if that changed, we would have more information here. Okay, let's go ahead and plug these in. 1 squared plus the square root of 5. Emma, what's the square root of 5 squared? Yes, these are opposites. So if you square something and square root it, they cancel each other out. Is this true? So we have just disproven that this is on the circle. It would be no, it's not on the circle. And if you graph it, you can see that it's not going to be. If I go over 1, I have to stay at 0. If I go over 1 and up anything, I'm off the circle because that's straight up and the circle is curving. Okay, any questions on these ones? How you decide if something's on a circle? Okay, we're going to review the theorems. We're not solving these, we are reviewing them. So I'm going to pick people to call on, and you tell me how to set up the problem so you could find x. So if you have your theorem sheet out, the bottom 4 on the back. Yes, all we're practicing today is those bottom 4. So the bottom right, we just did. That was the equation. And so the other 3 are our options for this. Martha, number 3, how do I set up a problem? Just a sec. Where's my other? I skipped one. Oh, there it is. I just changed my mind, Martha. Shifting gears. How do you set up a problem when they look like this, with chords that are crossing? We'll do that. You seem competent on this one. Let's do this one. Close. So I want everyone to look at their papers. This is the one that kind of goes outside it. So this is the right on top of our circle equation. Segment of secant's theorem. Did anybody write the words with the formula? Tyler, what did you write? What did you write under that? You wrote it? Say it, Zara. Okay, so what Martha said is the most common mistake on these equations. She did outside times inside, equals outside. Doesn't that feel like it would be right? There's something about that feel, I think because of this one, that is true. We do part times a part equals part times a part. So these ones that head to the outside of a circle, you have to be so careful. So come here and write something so that we don't make that mistake next time. Okay, now that we've corrected you, Martha, can you help us again? We'll get you started. 6 times what? That's the outside. What's the whole thing? What will be the distance from here to here? So from here to there, what is the length of that whole piece, the whole secant segment? Okay, Kate, what do you think? So I don't know if you guys can hear me. We would add them together, which this one's kind of nice because they're both numbers, so we can just do 9 plus 6. I don't know why I did such a ginormous parentheses. So the outside piece times the whole piece. And it has this random ratio. This ratio is going to work. Miles, can you set up the other part from the other secant segment? The 5 is, say it again? Yes. Sorry, I had to make sure I put the parentheses in the right spot. If I didn't put them there, it wouldn't have been correct. So outside piece is the 5. And you notice the whole piece, a lot of people were saying 5x. Do you see it like just squishing them together? So make sure that you're adding them up. And I think we're good at solving from here. If you struggle, once you set it up to solve, make sure you ask somebody. My biggest concern is we've got to know how to set them up. Okay. I don't know who I haven't called on. I always feel like I've called on everybody, but I probably skipped somebody. Is there anyone who knows they haven't been called on today? Oh, maybe I did good. Okay, Jetta, help us set up a formula to find x on this one. And we're not going to solve, we're just setting it up. Same formula. So she remember to add them, okay? Yeah, so my 4th period class, the person said 3 times x plus 5. Where did that 5 come from? So they've done some simplifying, some addition in their head. Both of these are perfect. It just depends on if you're someone who likes to do it in your head or who likes to follow the pattern first. Okay, so we could simplify this one. X and x is 2x, and 1 minus 1 is 0. Okay, and then you solve. There's one on the homework that it ends up being, you can't cancel out the x squared. So if you have a quadratic, stick it in your calculator, see where the parabola crosses the x-axis. If you have no idea what I'm talking about, ask me when we get there. All right, Tristan, help me set this one up. It's a little bit different. It doesn't have 2 secant segments. It has 1 tangent segment and 1 secant segment. Let's do it. I like it. X plus 4. That's a good start. I left a space. So this is the whole thing.
2. X squared. Leaves the piss out of me.
Oh, that's okay. That's okay. We'll just pick on someone else. Jose, can you help him finish it? Yes, outside piece times the whole entire thing. So that's pretty good considering you've written 0 formulas down, right? Tristan?
No, I realized 2.
2, but not this one.
Nope.
Please write it down right now. Write something down so you can do this on the test. All right. Lauren, help us set up this one. And we've moved on to a different equation. This is segments of secants and tangents. No, that's yes, you can simplify that to 3.
With random creepy people looking at the
Go shut it. Random creepy people, please go to your class. Love it. Yes. So again, if you thought in your mind, before Lauren said x plus 2, if you thought 2x, please be careful. If you're trying to make two pieces come together for an expression, you're adding them, you're not multiplying them. And I think it all goes back to these ones. These are the ones that are different. I don't know if you guys watch Sesame Street, but there's this whole, like, which one doesn't belong? These ones don't belong. They have a different equation. So, Miles, help me set up this first one into an equation, if that's true. Yes, there's no adding happening here. It's a segment times a segment. The product equals, and what would be the other side? Yes. Now this one looks horrible because there's x's everywhere, but that's how you set it up. He's full asleep. Okay, I won't call him. Grace, help me with this one. How would I set it up? What are these pieces that I'm getting the product of? And then we would solve for x. Okay, again, there's one problem on the homework that ends up being something like x squared minus 4x equals 0. And then kids are trying to add 4x, they're trying to divide by x, and it gets really complicated. So you can just do X Games. You can plug this into your calculator and see where the parabola crosses the x-axis. That's the fastest way. Okay, we're ready. After I pass these out, I will give some of you back your bell work with my response to your comments. Like I said, you don't have to keep it. I already have it in the grade book.